Thank you, Kara. As Kara said, I'll be going through the lake and water habitat section of this report, and I'll be focusing on the physical aspects of this section, and later on Tina will be discussing the habitat sections. In these pictures you can get a feel for what we've been doing over the past year or so, and all of these pictures were actually taken out at Lake Marion, where we were sampling for curly pondweed here, installing USGS gauges, so we've been quite busy with a number of different projects. So for Lake Marion, there were 5 key issues that we identified at the start of the project that we really wanted to focus on, and that the village of Mazomanie was really concerned about. The first of these was seepage, was how much seepage is Lake Marion currently experiencing, and how can we measure that? The second was water supply, identifying the current water supply and seeing what alternatives there might be if the dam were to be removed. Third was the water quality, assessing the current water quality conditions in Lake Marion, the surrounding ponds, Black Earth Creek, and in the alternative water supplies that we had identified. Fourth is the fishery. The fishery is a very important aspect of the Mazomanie community, and we wanted to assess what current fish are in there and in what numbers. And then lastly, the park itself, looking at the shoreline habitat around Lake Marion and what it's used for and how it could be improved upon. So first, we looked at seepage. And the main question we were trying to answer with seepage is how much water does Lake Marion need in order to sustain its current water levels? And this question requires taking into a number of components. These 4 components can be narrowed down to evaporation, precipitation, runoff, and seepage. So the first thing we did was look at historical records for precipitation in this area. And we compared this to a model that we ran that estimated the amount of evaporation that this area would be experiencing. And we found that these 2 numbers really canceled each other out. That in Wisconsin and Mazomanie, the amount of precipitation cancels out the amount of evaporation. The third part, estimating the runoff, we did so by estimating the watershed that goes into Lake Marion. And Lake Marion actually has a very small watershed. Over the course of years, it had a very negligible amount to Lake Marion. So the only real factor that we had to experientially kind of go at this summer was identifying the amount of seepage occurring. So if you look at this figure here, this arrow could represent the amount of seepage that's coming out of the lake. And there is no groundwater feeding the Lake Marion, so that did not factor into the water balance. There it is. So there are 2 methods we used to estimate seepage. The first was the use of seepage meters. These are big drums, one of which I'm holding in this picture right here out of Lake Marion. And these drums were placed into Lake Marion either at the bottom of the lake or the sides of the lake, as long as it was underwater, with a bag with a known amount of water. These bags would have been hooked up in this hole, you can see it right here. And then over a course of time, we measured how much water would flow through this known area. And this would give you a flow over the course of a time. For example, if you filled the bag up with 1 liter of water, we waited a half an hour, and if we get 980 milliliters after that half an hour was over with, we get that 20 milliliters per 30 minutes per this area. And that would give us a flow rate for that section. And we did this multiple times through multiple areas of the lake over the course of the summer. And this gave us a rough estimate about what, at those specific points, the seepage was for Lake Marion. However, in order to get a broader perspective, there was a second process that we used to estimate seepage. This was the full lake shut-off experiments. Now, there were previous full lake shut-off experiments that were done by the village, and these experiments were done in the same way we did, except they only lasted for 1 to 3 days. This experiment that we did, September 27th to October 15th, was one of the longer lasting experiments. And we did that because we wanted to see the amount of seepage when the lake levels were high, all the way through if we let the lake drain, what the seepage levels would be when the water levels were lower. In order to do this, we put boards. You can see Michelle here, standing next one. Yep, one of these boards at the culverts. And we close off the inlet, outlet, and the culverts on the connecting lakes. If you think back to the picture, Lake Marion is really composed of Lake Marion, the small pond, the large pond, and Black Earth Creek. So we put shut-off points where the Black Earth Creek would normally feed into the small pond, where the small pond would feed into the large pond, and where the ponds would feed into Lake Marion. All those connections were closed, including the outlet where Lake Marion would feed back into Black Earth Creek. In order to measure the water level, we installed 4 staff gauges and monitored the lake and pond levels daily. This required going out to Lake Marion and seeing how much the water level is dropping at each of these gauges every day. And with that data, we were able to estimate the amount of seepage. And before I get into the results, there are a couple of terms used on this slide that I want to go through. And first is the use of boards. We did some measurements using boards, and how Lake Marion is situated is that at the outlet, the water level of Lake Marion is controlled by big planks of wood, these boards. These boards are 5.5 inches tall, and normally there are 2 of them in place. However, over the past summer, they've had 3 boards in place. So when this experiment began, there were 3 boards in place. So you can see that's what this means right here. Now, if you were to take out one of these boards, the water level would go down 5.5 inches, and that would be the level at 2 boards. Now, these boards were left in, all 3 were left in during the course of this experiment. So we can watch the water level drop, and these are only used as reference points for if you're to control the water level of the lake, what level of seepage could you expect at that water level. So we found that seepage rate varies greatly with water level. As you can see from this graph, we had all the way from 462 gallons per minute at a total depth change of 0, all the way down to 99 gallons per minute at about 11 inches. And this x-axis here will show you the total depth change in inches, so that's the water level dropping, and the y-axis is in gallons per minute from 0 to 600. So this fluctuated greatly over the course of the experiment. So during the summer, the seepage has been very high. 3 boards in place, Lake Marion experiencing a seepage rate of 462 gallons per minute. However, for a normal year, what the lake would normally be at would only be 2 boards, 214 gallons per minute. And using this data, we're able to confirm that there are large amounts of seepage occurring from the vertical sides. So if you can imagine the lake kind of as a bowl. And as the water level drops, your area on the bottom of the lake is not changing much. That area is still underwater. The area that's really changing is what's on the sides. As the water level drops, area that was underwater is now dry. So what would account for this great change in seepage rate is the fact that water is no longer moving through the sides of the lake and has been drawn down. So you can see the main reason that we go from 462 gallons per minute at 3 boards and 99 gallons per minute at 1 board is because of the side level of the water. And this is a very important aspect to our recommendations for reducing seepage. So our recommendations for reducing seepage in Lake Marion would be first to dredge the lake. And dredging the lake can or will increase the depth of the lake. And we know we can dredge Lake Marion. Using wells, we were able to see that the clay layer beneath Lake Marion is at around 10 to 12 feet. And currently Lake Marion's deepest point is at 6.5 feet. So there is room to dredge down. So if you dredge down, then you'd be able to lower the lake level down a foot or whatever you like, and be able to reduce the seepage that way. So you no longer have that high side seepage that was occurring at a level of 3 boards. In addition, dredging would provide a lot of material that you could reconfigure the banks with. These banks are very permeable. These banks that were having the high seepage were just put there using previous dredge material. This material is very porous, it does not have a clay liner. However, if you were to regrade them and fill them in, you'd be able to reduce the seepage. Which gets us into the second recommendation, which is reconfiguring the banks. Because right now the banks they're very vertical. There's no nice grade to them, and if you were to add a grade in, if you were to add some clay to there, you could really reduce your seepage. And we calculated that if you were to reconfigure the banks, you could get a potential seepage reduction of up to 50%. So on to the second issue, which is looking at the water supply for Lake Marion. Currently, Lake Marion, here, gets its water from Black Earth Creek. Here's the dam, and the water flows into the side. So if the dam is going to be removed, then an alternative water source would have to be identified. And Jewel identified a couple sources, potential sources of water, and we wanted to explore these and see how viable they might be for the village. And the two ideas were to continue using Black Earth Creek water, not using a dam, but using some other diversion process, or using groundwater. So, in order to assess these options, we first collaborated with the USGS, which is the United States Geological Survey, in order to install these geoprobe wells. And here you can see a geoprobe in action. This is actually at Lake Marion, and we're working with them to install these wells. And these wells were pretty deep, down to 12 to 30 feet, and they gave us cores, and we were able to see where the clay layer was and how deep that was at, and just the soil profile of that area. In addition, we were able to take water samples from these wells, which is quite nice because along with water supply, we're trying to see which of these alternative sources of water would have the best water quality as well. So we took water quality samples from these wells, as well as Black Earth Creek, the ponds, and community members' wells. And then using that data, we were able to set up a hydrogeology profile, which is this thing. So this is a cross-section of Lake Marion, and there's a couple things to note about this hydrogeology profile. And first is that the lake actually sits above Black Earth Creek. Here's the creek down here. This is about 10, 12 feet down below Lake Marion. So the diversion process of using, or theoretically using Black Earth Creek water to divert into Lake Marion wouldn't work because you'd have to get the water uphill somehow, or you'd have to divert it much farther upstream from where Lake Marion sits. In addition, we found the clay layer sits below Lake Marion, but does not go up on the sides here. So you can see, using these arrows, the flow of water is bypassing this clay layer and moving towards the creek. Especially right here, on this bank, we actually walked around and you could see that this bank was very wet. It had a lot of water coming from Lake Marion, seeping towards the river on this bank. In addition, from our water quality samples, we identified that Lake Marion was very high in phosphorus and sediments and low in dissolved oxygen. This made us believe that Lake Marion is currently a eutrophic lake. In addition, Black Earth Creek water was also very high in phosphorus and sediments, so water quality is very poor in Black Earth Creek. However, the groundwater was relatively low in phosphorus and contained no sediments. And depending on how deep you go, it correlated positively with how much phosphorus there was. So the lower you went, the lower your phosphorus levels were. When our low dug wells here would have higher phosphorus levels than wells we dug at, say, 30 feet. So, given that, we recommended groundwater as the new water source for Lake Marion. We identified that it's technically feasible and has the possibility to improve water quality for Lake Marion. However, we did not determine the pump size and the possible pump location. These are things that would be decided by Jewel Associates with our findings. Given the water quality data that we found, we came up with some recommendations for improving the water quality of Lake Marion. First would be managing the amount of nutrients that are being input into Lake Marion. One of the ways to do this is to widen the buffer zone, and many of these improvements will be going through in more detail later in the presentation. But for now, if you widen the buffer zone, you can really prevent a lot of inputs from getting into the lake, because currently it's mowed right up to the edge. You can also reduce turbidity by managing the carp. There's confirmed presence of carp in Lake Marion. We've seen them while we're out there doing our field studies. And these carp have been known to really stir up the sediments and release that phosphorus back into the water column. And the third option would be preventing a winter fish kill by providing artificial aeration. And one way this helps with nutrient management has to do with the phosphorus that's currently bound up in the sediments. This phosphorus binds with iron in oxic environments where oxygen is present. If the lake becomes anoxic, this dissolves back into the water column. So providing a source of aeration, either by aerating the lake directly or indirectly, just at the source, for example, the groundwater, you can prevent that from happening. You can prevent that phosphorus that's currently tied up in the sediments from being released into the water column. So now Tina will be getting into the fisheries section of the report.